Hello everyone. Welcome to Controllerstech. Today in this video, I am going to show you how to work with the temperature sensors that only uses one wire to communicate. In this video I will cover DHT11, DHT22, and DS18B20 sensors. The first part of the video will be common to all three sensors, as I am going to use the same pin for all three of them. Let's start by creating a project in STM32 Cube IDE. I am using STM32 F446RE controller. Give the name to the project and click Finish. In the CubeMX, first of all I am setting external crystal for the clock. I am using timer 6 for creating delay in microseconds. Pin PA1 will be the data pin for the sensors. And I2C is for connecting the LCD 1602. Let's set the clock now. I have 8 MHz oscillator on board. I want the controller to run at 50 MHz. A PB1 clock is also running at 50 MHz, and that's where my timer 6 is connected. I chose low frequency for the HCLK, because some of you complained that the microsecond delay is not working at lower frequencies. I am setting timer to create delay in microseconds. If you don't understand it, check out the video at the top right corner. Click Save to generate the project. I am including I2C LCD related files in the project. If you are not using STM32 F4, you need to change it accordingly. If you are using any other I2C, change it here. I will build this code once to check for any errors. This is for sprintf function. We need to write some functions first. Delay is to create delay in microseconds. Basically, set the counter to 0, and then wait for the counter to reach the entered value. These are some variables that we are going to use throughout. These are functions to set the pin as input or output, based on the requirement. You can change to pull up, or no pull, if you are not getting the data from the pin. Now the DHT11 specific part starts. Let's take a look at the datasheet. This is the overall communication of the sensor. It starts with sending a start signal to the DHT11. MCU sends the start signal by pulling the line low for 18 milliseconds, and then high for 20 to 40 microseconds. I am defining the pin and the port for the DHT11 sensor. This is the function to send the start signal. First the MCU will pull the pin low, and then keep it low for 18 milliseconds. Then MCU will pull the pin high, and keep it high for 20 to 40 microseconds. After that MCU will release the pin. After receiving the start signal, DHT11 will send a response to the MCU. To do so, it will pull the line low for 80 microseconds, and then high for 80 microseconds. This is the function to check response. We first wait for 40 microseconds. That means we are here on the timeline. Then we check for the pin to be low, which is actually low. So, we will wait for 80 microseconds. Basically, we reach here on the timeline. Now we will check if the pin is high. If it is, that means the sensor is present. Or else, the sensor is not present. Finally, we will wait for the pin to go low again. Now after transmitting the response, the DHT11 will start transmitting data. Before transmitting any bit, it keeps the line low for 50 microseconds. Which is followed by a high for 26 to 28 microseconds, if the bit is a 0, or a high for 70 microseconds, if the bit is a 1. This is the function to read the data from DHT11. First we will wait for the pin to go high. Which means we will be here on the timeline. Now, we will wait for 40 microseconds. If a 0 was received, we will be here on the timeline, and the pin would be low at this point. Or, if a 1 was received, we will be here, and the pin would be high. Based on the result, we store the data at the respective position. Let's start by starting the timer first. Initialize the LCD. I am sending this string to the LCD. Wait for some time. Clear the display. Now, start the DHT11. Record the response from the sensor. Sensor will send 40 bits of data, which includes integral RH data, decimal RH data, integral temperature data, decimal temperature data, and the checksum. So we will read 5 bytes of this data. Temperature data is from the integral part, and RH data is also from the integral part. Also, these are the functions to display the temperature and humidity data on the LCD. I am writing display functions in the beginning, so that they can be common to all other sensors also. And in the end, give some delay. There is the floating point error, because I am trying to convert the float into character. Go to Project Setting, C++ Build, Setting, Tool Setting, and select uprintf float. The project builds successfully. Let's debug the code. Let's see the result on the LCD itself. You can see the data being displayed on the LCD. Notice the increase in temperature when I am touching the sensor. This is it for the DHT11. The next part of this video will cover the DHT22 and then DSB18B20. You can download the code from the link in the description. First we need to define the pin for the DHT22. DHT22 start sends the start signal to the sensor. Let's take a look at the DHT22 datasheet. To transmit a start signal, the MCU needs to pull the data line low for at least 1 milliseconds. And then it needs to pull the line high for around 20 to 40 microseconds. The pin must be released after that. On receiving start signal, sensor will send the response. It will pull the line low for 80 microseconds, and then high for another 80 microseconds. Now, we will first wait for 40 microseconds. Which means that we are here on the timeline, and the pin should read low here. If it does, we will wait for another 80 microseconds. That brings us here on the timeline. The pin should read high here, and that indicate the sensor's presence. After that, we will wait for the pin to go low. To transmit data, DHT22 will pull the line low for 50 microseconds, followed by pulling it high for 26 to 28 microseconds, in case the bit is 0. To transmit a 1, DHT22 will pull the line low for 50 microseconds, followed by pulling it high for 70 microseconds. To read the data, we will wait for the pin to go high. This brings us here on the timeline. We will wait for 40 microseconds then. If the bit was a 0, we would be here after 40 microseconds. And the pin would read low. If the bit was a 1, we would be here, and the pin would be high. We will record the bit at the respective position, and wait for the pin to go low, before reading next bit. Inside the main function, first start the timer. Initialize the LCD. I am sending this string to the display. Wait for some time and clear the display. Here are the functions to display the temperature and humidity on the LCD. First of all, send the start signal to the sensor. Read the response from the sensor. Sensor will send 40 bits of data, which includes integral RH data, decimal RH data, integral temperature data, decimal temperature data, and the checksum. So we will read 5 bytes of this data. Now we will combine the integral and decimal part of the data. Finally, convert the values to the proper float. Let's build and debug. As you can see here, the values of temperature and humidity are being displayed. This is it for the DHT22 sensor. The next part of this video is about DS18B20. You can download the code from the link in the description. Here is the function to create delay in microseconds. These functions are used to display temperature and humidity values on the LCD. Functions to set the pin as output or input. First of all, I am defining the data pin for the DS18B20. It is connected to pin PA1. Start function is to send the start signal to the sensor. It starts by setting the pin as output. Pull the pin low and hold it low for 480 microseconds. As you can see in the datasheet, the master have to pull the data line low for 480 microseconds. After that, We will release the pin by setting it as input. On receiving the start signal, sensor will send the response to indicate its presence. So we will wait for 80 microseconds. We should be here on the timeline. Now we will read the pin. If the pin is low, the sensor is present, as it's the one which pulled the line low. Now we will wait another 400 seconds to complete the response cycle. This will complete the initialization of the sensor. Next is the write function to write data to the sensor. To write a 1, we must first set the pin as output. Then pull the pins low, and hold it low for 1 microseconds. You can see that here. After 1 microseconds, we must release the pin, by setting it as input. And wait for around 60 microseconds for this cycle to get over. To write a 0, we have to again set the pin as output. Then pull the pins low, and hold it low for around 60 microseconds, and finally release the pin, by setting it as input. Read function reads the data from the sensor. To read the data, we must set the pin as output first. Pull the pin low, and hold it low for 2 microseconds. Now we will set the pin as input, and read the data pin. The microcontroller is going to sample the data here. And if the pin would be high, which means that we are here on the timeline, and the data read would be a 1. If the pin would be low, the data read must be a 0. And at last, we have to wait for 60 microseconds for the cycle to get over. Inside the main function, first start the timer. Initialize the LCD, display some string on the LCD, wait for some time and clear the display. Now, inside the while loop, let's take an example from the datasheet. First send the start signal, and look for the presence of the sensor. Next, write the skip ROM command, and write scratchpad with convert temperature command. Again send the start, read the response, and skip ROM command, and read scratchpad command. Read the 9 bits of data. And here, we finally calculate the temperature. Let's build this, and this time I am directly running it. You can see the temperature being displayed on the LCD. When I hold the sensor, there is a rise in the temperature. If you are having issues with the temperature values, for example, if the value is 4095, you can change this delay here. Don't decrease it too much, I am reducing it to 50 microseconds. As the time for this cycle is 60 microseconds, so try to keep the delay close to this value. You can also change this pull up to no pull. This is it, guys. I hope you understood the video. You can download the code from the link in the description. Keep watching.